I'm not gonna read the whole task because you can pause the video and read it yourself and understand what do you need to find. The only thing I have to mention is that here is not just one person with one formula, but two people, and we have to find something in common. In this case, in the first task, they ask the time we have to find, and the other important stuff is compounding continuously in both cases. For that, we have to write the formula. We have to know the formula of continuous compounding, which is a equal to p multiplied by e in the power of r multiplied by t, where t is a period, where r is the interest rate, e is just a number that we have. It's around 2, something like that, 272 if I'm not mistaken. P is a prime amount, which is the same as an initial amount, and A is just final amount. So here we're gonna have two compounding formulas, one of Paul and the other is of N. I have no idea. So okay, we just need to write down both with the values that we are given. So Paul is investing 3,000. His interest rate is 4%, which we're gonna write like this, 0.04 multiplied by t. For n is gonna be 2,800 multiplied by exponential in the power of 6% multiplied by t. So we can divide both sides by 2,800. Let's do it. So we're gonna have in the right side only the exponential part. So we can rewrite this part just as 15 divided by 14 multiplied by exponential is equal to exponent in 6%. So now we divide both sides by exponential in power of 4% multiplied by t. So here we're gonna have just a fraction of 15 over 14 is equal to e in power of 6% divided by e in power of 4%. And if you know the properties of powers, when the base is the same, and if you divide them, the power is gonna be just subtracted. So it's basically 6t minus 0.4t, so like 1 exponential. So we can basically rewrite it as 15 over 14 is equal to exponential of 0.02t. And now we need to make both of them as natural logarithms. So ln of 15 over 14 is equal to ln of exponential of 0.02t. And you know the properties of exponential when you take, so natural logarithm is basically the same as logarithm in base of exponential. So if you put here instead of x this value that we need, so if the base is the same to this value, it means that we can just rewrite it only as a power of exponential, or the power of another value if it's logarithm, so it doesn't matter. So basically on the right we're going to have the same value of 15 over 14 of natural logarithm is equal to 0.02t. Now we divide both sides by 0.02, which means ln 15 over 14 is equal to divided by 0.02 is equal to t. So if we calculate these values, it's gonna be around 3.449, which is almost the same as 3.45 years. Don't forget that this period was in years. So in the second task, we have a Frida that invests 2,000 euros in her bank account with, it's supposed to be some particular number of interest rate. So don't forget that here is also continuously compounding. So the time is the same as Paul and Anne have, and they say that the money that she wants to earn is supposed to be the same as Paul and Anne had. So the only difference is supposed to be the interest rate. So first of all, I think we need to find the money that Anne and Paul had in the end. So basically this is just the same formula, and let me just choose, for example, the numbers of N is 2,800 in the exponential of the power of 6%, and you remember that we had the time of 3.45 years. So I already calculated this value, and it will be around 3,444 euros. It's always some approximate values. So basically it means that for Frida, she has to earn 3,444 euros by investing 2,000 euros multiplied by some certain interest in the same amount of time. Again, we divide both sides by 2,000. So it's gonna be like this. It's equal to R multiplied by 3, like this. And if we divide, and if we calculate these values, it's gonna be around 1.722 is equal to exponential. So basically that's it, and now we're gonna do the same stuff with the natural logarithm. The base is the same, so we just put these values. It's gonna be just 3.45 multiplied by R, and ln you could have just save the same fraction and make it ln like this, like the difference will be the minimum. So if we calculate these values, it's going to be 0.1575 as R, but don't forget to multiply it by 100% to make it as a percent, so it will be 15.7% of rate interest that need. You can also check if you're not sure about your answer, and if you want to check it, just put the same values. Then let's see, she's investing 2,000 multiplied by 15.7%. So basically there are more numbers, so like my calculator shows that it's 15.75.322 and many numbers, but you know that it's just approximate numbers that we need. We don't need that precise values. So multiplied by 3.45, and if I calculate these values, it's gonna be very close to 3.37, which is not that close as we wanted, but it's probably because I use these values instead of using the fraction. I believe that if we use a fraction, it's going to be almost the same. But the most important fact is that interest rate is very close to the actual answer. So just if you want to have exactly 3,444, use a fraction, so make it like ln of 3,044 divided by 2,000 and divided by 3.45 is equal to R. And if you want to check it, you can use instead of this value, you can rewrite the whole big fraction like this, divided by 3.45 multiplied by 3.45. So basically these two values just will be simplified. So the only thing that you need, guys, is just multiply all of the other stuff, and it's going to be just like this. So you can see that with values, with the properties of natural logarithm, you can rewrite this just as 3,444 divided by 2,000. This two will be simplified. So if you want to be very, very precise, this is like that.